Okay, guys, by now you know how to manipulate your flow control, what kind of data structures you have available to you. In general, you should be fairly comfortable inside the Blueprint editor on a single Blueprint basis. However, you should be completely clueless about how do you send information between blueprints? How do you trigger particular events from one blueprint to another? If an orc gets hit by a sword and the sword has a particular damage, how do I send the damage from the sword into the orc so that the orc could calculate its health? Or vice versa, right? If the orc has a particular health amount and you want to heal that orc, it'll just act like, how are you going to send the actual health, extra health value to the orc? How are you going to notify it? There's several ways of executing this particular behavior, making it possible. Now, the first one, of course, is to have a unified library. In other words, to make sure that the orc is going to have 100%, the function enabled, whatever function it is. So if you have 1,000 orcs, all of them orcs are going to have the receive health function. A very simple way to do this would be to create a blueprint function library. Of course, this is a basic library, so a library on its own. I'm going to call this my library EX. And this library, I currently have only one function. I'm going to say heal, right? And this is my heal function. Nothing else. I'm not going to add any inputs nor outputs because it's kind of pointless. And I'm simply going to call this inside anywhere because this library is available globally inside your engine. Therefore, I could grab, let's say, my character, and I'm going to say heal. And here, as you can see, I've got my library EX, and I can grab my heal. And then I can do whatever it is I wanted to do inside the function. Now, the cool bit is here that I can actually define this function inside the function library. And let's say I have an input and an output. If I actually don't collapse them, so this is going to be an integer or a float, and this will be also a float. So I'm going to compile, close, and now I have my floats. Obviously, these are not named, but in general, you don't have to. These are already defined functions that are ready for use. Now, you might think to yourself, yeah, but what if I forget to do something like that? We'll get to this in a moment. It's a very important thing, but I want to talk to you about casting and the reason why it's important. Let's say we're currently in the player character, and the game mode has a variable which will be the overall players. Let's say enemies on the map, enemy count. And this is going to be, of course, an integer because that's what enemies are. You can't have half an enemy. I'm going to compile, and I'm going to say that by default, there's going to be 100 enemies on the map. Very simple, right? Now, in my character EX, you might think a very simple way of doing this is simply right-clicking and grabbing character count. Enemy count. However, it's not available. If I turn off the context sensitive, yeah, I'm going to get my enemy count. And let's see what happens if I get it. That's just fine. However, it says target self. What is that supposed to mean? Well, I don't know. Let's try to double the enemy count, right? So if I go ahead and say doubler, because the doubler is available in our game mode EX, I get my doubler as well. It also has a target thing on it. Now I'm going to go to my minimal here, by the way, game mode here, and I will change my doubler to a non-pure. I'm going to desecrate my function here so we have executable pins on it. And perhaps it would be best if I'm going to just simply convert this. So I'm going to drive this into my value, and I want to double whatever value I have as my enemy count. You might be asking yourself, why would you want to grab the enemy count from the game mode and double it here? I could just as well create my own, like this is a health variable, for example. I could use my health variable and dunk it instead and multiply my health, or in this case, double it. So let's see what happens. I'm going to go ahead and simply activate this by saying, well, when I press spacebar, I will fire this event, and it will give me the output of a doubled value, won't it? So let's print the string. And this string will essentially give me my health, or in this case, the enemy count. And we'll keep doubling the enemy count all the time. What if I want to edit this? What if I double click this? What do you think is going to happen? Do you think I'm going to be able to define this inside this blueprint? No, no, no. I'm going to go to the game mode EX, and I'm going to go over here to the actual definition of the function. Unlike the library, this function is defined only in the game mode itself. So if I want to use that function, I need to access the game mode. You might be thinking, yeah, well, that's great. We are all good and done. What's going to happen if I compile? We got loads of errors. Now, why do we get these errors? And here's the real interesting bit. That's a very important thing to understand. Who owns what and what kind of scope do these things have? Currently, the doubler is asking for a target. Now, right now, the target is self. In other words, we're kind of running this on the character EX blueprint. However, it is imperative that you understand this. We need to find the appropriate reference to the appropriate object that holds the appropriate function if we want to call this function. Okay? That's imperative. That's why that's kind of encapsulating the function itself. Generally speaking, you wouldn't want to be doing this. You'd be utilizing something else, such as an interface. Later, we'll talk about an interface in a little bit. But what I want you to understand is that right now, as far as the engine is concerned, we're trying to run a function that does not exist. There is no such function here, so there's no way we can run it. How can we run it? Well, currently the target says that it needs a type of object called game mode EX. So let's get the game mode. Get game mode, and that's my game mode, right? We need to get the game mode, and we can simply plug this in. But we can't. Why is that? Because the game mode is a very abstract term. It's not exactly a definition of what a game mode is, and that is an issue. Because this needs a specific type of game mode, and this needs a game mode EX. How do we do this? We simply cast. Cast to game mode EX. And there it is. Notice that I'm casting to an object and not a class. You don't want to be casting to a class unless you know what you're doing. So I'm going to hook this up, and as a game mode EX, so currently it's a lot like, this casting thing is a lot like a true and false statement. Basically, it's asking, is the game mode that we currently have a game mode EX? And if it is, we will continue execution. If it isn't, we will report a failed cast. And afterwards, you know, we can do some error management or error reporting or whatever it is you want to do. Maybe throw a problem or crash to desktop, whatever. The point is that without this cast, I am not able to actually utilize whatever the game mode possesses. Now, I could say that as the game mode, I will execute this doubler, and I will be, you know, completely within my right to do so. However, it's not a very clean way of working due to the simple fact that sometimes you might need extra uses of this reference. So let's say I got my game mode, but I also need it for my value. So this is quickly going to turn into spaghetti sauce if I decide to, you know, have a couple of hundred functions here, and then it's going to turn real ugly. Maybe I need to cast again. Maybe I have to cast 100 times. So this is not ideal. What I like to do, generally speaking, if I'm going to use a blueprint like a reference several times, I will simply promote this to a variable and then set it up in such a way that the variable is cached. I'm going to call this game mode ref, and you could even put it into its own category of references, refs. So it's in its own category of references, and now as the game mode EX, we can simply do the target bidding. We need to cut this line here, unfortunately, like so. And if we compile now, we're not going to get an error here, but we will still get an error here. Now I could, like I said, simply grab one of these here, but for a cleaner setup, I might as well just use this. I can compile, and everything will work correctly. Now here's the interesting bit. Now that I have this reference, I can pretty much grab, it's as if I have this object in my component list here. In other words, it's going to be always available by default. We'll be talking about the component in a moment, by the way. So as you can see, I have my component here, or in this case, the reference. I can grab anything. Maybe I want to get the explanation or whatever. What did we have? I need to turn on context sensitive again. Get EX. Was it? What did we have on our game mode? Explanation. Yeah, there we go. So this should, is it private? Is the explanation private? Oh, enemy count is actually non-private. Well, it is not private. Okay, explanation. Is it private? No, it isn't. I need to compile this. And here, once I have my game mode, I should be able to get explanation. So there's another thing I could get. So all the variables, everything that is available to me in game mode is also available to me here, and I can perform really any type of functions or logical operations on the data itself as I see fit. Now, if I play this and I press spacebar, nothing is going to happen. Why is that? Because I'm currently, I believe, not doing something correctly. I'm printing out. Oh yeah, nothing is happening because our character doesn't exist in the game. We have to actually have it as part of the scene, since it only gets initialized whenever it's being spawned. If we want to spawn it, it has to be like so. Of course, we don't have any skeletal meshes here. So if I play now and I press space, I still don't have it. Why is that? You have to give me a second here. My player controller is my player controller, my game state, player character. Okay, default player pawn. Let's use the character EX for that and play. And as you can see, basically you need to connect. Usually you'd have this kind of stuff in the player controller, not in the actual geometric object, in other words, the in-game actor. But as you can see, I'm simply doubling this stuff. Now the reason it stays at 200 is because I'm not resetting it to the original value. So I could say, here's my enemy count, I'm gonna double it, and once I double it, obviously you could set this up in the doubler itself. So if you want to double the value, you would set the new variable to whatever it is. Of course, you'd need to have access to it, and then you would output it. Now in my case, I'm gonna have to do this by hand, since this is just an example, but I could say set value, because it's currently in the game mode, right? It will also require a reference for the game mode, because we're asking it, telling it, hey, we want to set your value, which is currently located in our game mode. What can we do about it? We can simply either grab the same reference here or re-reference it over here. Again, this is already in memory, so it doesn't matter how many times you reference it. It's always available for you in memory. It doesn't matter if you have it 1,000 times here or once. Okay, so just don't turn this into spaghetti sauce very quickly. Now, if I play this, I'm going to have 204. Oh, wait. Why am I not getting this? Let me see here. Oh, crap. I'm setting the value instead of the enemy count. My bad. Jesus. My bad. Sorry, guys. Set enemy count. That's what we want. Kind of got confused by the float there. And then we've got the enemy count. Truncate, whatever. So kind of getting really crowded here, but I hope you guys kind of understand what I'm doing. So I'm going to compile and play, and now we should get a doubling value every single time that we press spacebar. Fairly straightforward, very easy to understand. We grab a reference to whatever it is you want to use from that, from anything really. You cast it to see if it's the right thing, and then you send it over. In order to really hammer this point down, I'm going to use an analogy which I believe everyone will be able to relate to. Imagine you're in the military, and High Command, which is the programmer, decides to fire. He gives the command, fire. Now the lieutenant, being the good lieutenant he is, perfect soldier, he will execute the command despite how ridiculous it sounds. So it's going to go to the soldier in the warehouse. It's going to say to the soldier, soldier, I want you to fire. Now, the private is a little bit mouthier and a little bit smarter than the lieutenant, because it has to execute the command, actually, not just receive it. So he's going to ask his lieutenant, but sir, what would you like me to fire? Now, the lieutenant doesn't really have an idea of what has to be fired, and that is the problem, right? In this case, this would be like the lieutenant telling him, right, I want you to fire your primary weapon, okay? And if that's the case, then if you have first of all, give me a weapon. There's your weapon. Is it a primary weapon? Yes, it is. Then fire it, or do whatever it is you want here, right? So if you're going to be doing this kind of communication, make sure that you understand that the object you're operating with needs to be defined after you get it. That also applies to any kind of event that returns objects, by the way. If we take a look at the mesh, for example, which is currently inherited, as you can see, it's got loads of different events. Now, these events have basically returned values of whatever type. In this case, if we take component overlap, so this will return anything, whenever anything overlaps with our player character, it will return It will fire off this event from the execution pin because it will trigger. And of course, it will give us the idea of what overlapped with us. First of all, it's going to be which overlapped component did we get. What's the other actor? What's the other component? Other body index, if we have any. From sweep result, you don't need to bother with that right now. It has basically a special type of overlap. But the point is that I could grab this other actor and cast to see if it's the right actor. So maybe I want to get, I only want to overlap with pawn. Cast to pawn. Right, pawn EX. Whatever I'm overlapping with, it has to be a pawn EX, which is kind of over-inclusive because anything below a pawn will succeed with the cast. But if you want to go further down and say, I want this to be a particular character or a very specific object or an actor, this has to be that kind of actor before I can continue executing my line. So I hope this is fairly well understood by now. I'm going to leave this here for now because I do want to use the actor bit later down the line. I'm going to compile and we're going to move into the next bit of objects. So for now, you know that you can have your function library, which is enabling you to write down functions, and also you can cast stuff around. And what other options do we have? Well, there's a thing called an interface, and it's a fairly powerful tool allowing you to sort of bypass the cast itself. And that's a really powerful thing indeed. How does that really work though? Well, first you create a blueprint interface. And I'm going to say, this is damageable. Generally speaking, whenever you name a blueprint, the naming convention is there's an I behind it saying that it's an interface and anything that is able to do. So in this case, damageable because I want to make sure that whatever implements this interface is capable of receiving damage as an idea. So let's open it up, and you will immediately see a similarity between the library over here and the actual damageable. They're essentially a definition of a function. Now in the damageable's case, because this is an interface, it actually cannot initialize a function. In other words, you can't really define the logic inside the function. You can only define the abstract generic function. In this case, we would say that this function should be damaged. Whatever this is, okay? Now, just like the library, you can actually keep adding and removing inputs and outputs. So in this case, I could create several things that are responsible for transmitting damage back and forth. So let's go ahead and I say, I'm going to add a new function, and this will be receive damage. So anything that is damageable must be able to receive damage, and it will have, let's say, an input. Okay, so this input will be in the form of an integer or a float, and it will be called damage amount. So far, so good. Next, we have something else, such as maybe we need to update the health. So remaining health, or damage applied, or if you have armor. So in this case, let's just say we have health remaining. Okay, health remaining, or current health, or whatever. So the received damage would have something like, I don't know, maybe armor. So let's take a look. Let's add another here, and we're going to say armor in order to have some kind of calculation, right? So we'll have an armor, and this armor will be, let's leave it at a float. Remember though, we have one thing that has no inputs, no outputs, one thing that has only inputs, one thing that has, well, it needs an input and an output. So let's take an input and an output. So this will be a health, such as this, where it will be damage received. No, how should I name this? Current health, current HP, final HP. Right, fairly straightforward. And of course, we could have one more. I'm struggling to think of reasons now to have something that has an output as well. Just the output, by the way. Let's see. Let's create an output and think of it on the fly. So we have a damage situation. Let's create an output of Boolean, and it's going to be is alive. Okay, is alive. Well, that's not the right way to say it, of naming this. Is alive. generally speaking, whenever you talk about blueprints, you need to have to ask the question sort of, and then alive would be your condition. And life check. No, existence, no. Just life check. All right, so this life check only has an output. Now, of course, this is kind of not ideal because at the end of the day, you kind of need your health, but we'll make this work. So currently, notice we have a damaged, which is nothing, receive damage, which is something, health remaining, which is something, and life check, which is also something. One of them has an output, the other one has an input, and the third one has both an input and an output. That's very fancy, but how do we exactly use that, especially since we did not define any logic here? That's where the power of the interface comes, because anything that is damageable, okay, can implement different logic in it, right? As long as it has these four functions, it's like a contract, right? If you want to be damageable, you need to have these four functions, and that is final. How you work with them, what you do with them, it doesn't matter. As long as you have them, you are damageable. That's how it works. That also allows you to utilize, in this case, for example, you could say, maybe I want to be casting to damageable. Like, for example, you can cast to damageable if I actually compile this. As you can see, I can cast to an iDamageable type. And then I can, as an iDamageable, so anything in this case, not just, it's a more generic expression, anything that implements the iDamageable, in this case of a cast, can perform any function that an iDamageable possesses, right? So as you can see, we got a class, and you see we've got the interface calls on all of these, okay? So that's pretty cool on its own, in its own manner. I'm going to delete this for now since I do want to implement this after all. And we've got my library. I'm going to close this. No need. Leave the iDamageable here just for reference points. And we're going to keep the game mode off for now, over here. So here's my iDamageable situation. How can I utilize this? Well, first we need to implement it by going to the class settings and simply implementing our iDamageable, as you can see here, or simply type damageable. We're going to implement our iDamageable interface. I'm going to compile. Notice that as I implemented this, I've got a set of things, right? I've got life check and health remaining, and for some reason I do not get the extra things which are available to me otherwise. iDamageable. What did we get exactly? We got life check and health remaining. So life check, health remaining. We do not have receive damage, which requires an input. We do not have the damaged, which is simply nothing. Let's try to call these and see if this is just a gimmick. Let's see, damaged. So here we have two options. One is called event damage, which is the event available to us in this object. So I'm going to click here. And as you can see, it has a small icon. For some reason, it is actually not available to, I think only the functions are defined here. So here is our event damaged. Then after we damage something, notice the function, the icon again. Then we need to call something else, which would be in this case, receive damage. We do need to receive the damage, don't we? So receive damage. There it is. Now in this case, I'm calling the function. As you can see, I probably shouldn't have called it so fast. Receive damage. As you can see, we've got add event receive damage, which is the outputted event. Okay. Notice that it's the outputted event. So whenever it's called, right, I hope you're seeing this. The event can be a trigger, whereas this requires an input, right? This gives you an output of damage amount, right, and armor. This requires an input of damage amount and armor. If I double click this, I'm not able to actually change it. So this is kind of pointless, really. You don't want to be using a function whenever you don't have an output. It is, however, possible, of course, to receive damage. You can also call it on an interface call. Now, there's the difference between these is that this is being called, as you can see, the target is character EX. In other words, itself. In this case, this is anything, like in this case, the target is anything that is iDamageable, right? Fairly simple to understand, I hope. Now, I'm a little bit confused myself as to why these things exist in such a way. My guess is, I mean, one requires a reference, one doesn't, but then this case, this doesn't need a reference either. So you could receive damage in another way. For example, we could grab, actually that's all of the possible options here. I think there are others as well. Yes, you can actually message this, but it's only for outside. I'm gonna demonstrate the message later. What you need to consider is simply whenever you have events with inputs, in other words, in this case, our received damage has only inputs and no outputs. Generally speaking, you would only want to use the received damage, because in the face of received damage function, such as this, you want to call this, there really is nothing you can do with it, right? You simply can take it in, but you can't double click this. There's nothing you can implement here. There's no logic to be done. And therefore, in my opinion, I've never actually had to use this before in my life. Okay, I only have this understanding from just reading the documentation and all that. I really don't see why would you use that, because you can't really set anything. You can't get an output out of this. So it's just like a dead end, right? So for whatever reason, if you need it, you might need it. Maybe it's a different type of function. Now, when it comes to the life check and the health remaining, so we've got our event received damage and an event damaged. As you can see, these are two different events, both being driven by the interface, right? Important thing. Now, we need to grab the life check, which is, of course, here, and we need to grab the health remaining, which is, of course, here. So how does that exactly work? Very simple. Currently, it's being called, of course, this is a function now. These are functions, right? This only has one output, right? Life check only has one output. Doesn't have an input, but it has an output. This has both an input and an output. Now, how does that operate? Let's see. So the target is, let's say it's received damage. Okay, we're going to send received damage, and we need to see the damage amount, and we need to use the armor. Of course, currently we have a current HP, and that's all this thing takes, right? So in this case, we'd have to run a calculation between these two things. Let's just say that in my situation, I will use, so we got a damage amount, and I will simply subtract the damage amount from the armor from the damage amount. So I'm going to say float minus float, float minus float, and I'm going to subtract the armor from the damage amount. So I'm going to reduce the damage amount essentially, okay? Next, I'm going to simply pump this into my current HP. Actually, in this case, it's not what I need to do. I need to grab my current HP, which would be, in this case, health. And I need to change this to a float. And this health, change variable type, please. Thank you very much. And I will simply use my health. I already have it here, so that's great. I already have it here. That's amazing. So that's my health. And I will simply suck this down into my current HP. But I need to also subtract from my thing. So let's just say that for whatever, by the way, in this case, you would want to have an input of a damage amount and an armor. Okay, you wouldn't want to have it. I'm just explaining, this is doing the very convoluted thing here just to show you different ways of working here. Okay, generally speaking, this would have also an input of damage amount and an armor. You could even do it like that. Just instead of doing what I'm going to do now, you could simply go into your received damage and simply add a couple of more inputs as to, whatever it is, not received damage, my bad, a health remaining, and add an input for, for your armor. All right, but in this case, we won't do that. So we need to implement this, right? How are we going to do this? If I double click, if I double click, and there it is, I will get my function. This is just like a regular function. The logic between these two nodes here does not matter as long as, they remain intact. So I could grab my current HP, and perhaps since this is a health remaining type deal, I could say maybe what I want to do is divide my I think it's possible to get percent. Yeah. As percent. No, just regular percent. So my current HP, and I'm going to say that I believe A over B. So let's just say it's 100%. Over 100%, see how much. Well, you don't really know your current percentage, so you kind of need to see. Let's say my current HP is, let's say my max health is my current HP, okay? I'm kind of making this really ridiculous now. I need to get a max health as well, max HP, and I'm going to drag my max HP. Oh, of course, this could be a local variable as well, but in this case, let's not bother with it. my maximum HP would be, of course, no point to set it, compile. Maximum HP should be, let's say my max HP is 250, and I currently possess, well, I currently possess 250, so that's great. I want to get the percentage of that, of how many percent of experience of HP I actually have left. And I'm going to output as my final HP. Probably not the best naming convention since I kind of have health remaining, but since I'm going to be outputting percentages, that's really not a big deal. Assuming, of course, I didn't screw up the division here. So, how can we continue with our situation? Well, we've got our current HP, which, by the way, is a function, so it requires to be fired, right? So, grab my health here. I'm going to simply disconnect this. I will subtract this from, again, I'll duplicate this essentially, and I will subtract this damage from my health. Like so. Like so. As you can see, very simple. And then I'm going to dunk this into my remaining health, or current health, in my health remaining. Now, all I have to do essentially, of course, is to hook these up. So like this. My health is getting in the way, so maybe something like that. It's getting very confusing here. That's why you would ideally want to have these inputs and outputs in your health remaining, because you don't want to be doing this on every, on every component. But let's just say that I have my health remaining, and I'm gonna use my print screen to be the output. And the print screen will say, I just double clicked it by mistake. It'll be 15 seconds long. It'll be in the color of red because this is the damage type deal. Maybe let's keep it green for now. And it will give us the final HP. So this is going to be anything that is green is the HP, okay, of our character. Now, we could continue, by the way. Let's say we grab this and we could say, well, because our health is local, in other words, our health is housed within our character EX, I could grab my health, right? Or I could simply grab my current health, right? Inside the life check. So let's say my final HP I would have to set my health though. Okay, let's do this correctly. Let's do this correctly. Set health. All right, much better. And then this health would actually be over here, and this final health would be over here. So it's being set as the new health, and now I can utilize it later down the line, such as this, in this fashion. There's my health. In this case, I need it inside the life check. If I double click it here, you can see my life check is alive. And as you can see, my current health, I can use it, and I'll basically check if it's less than 0. Less than or equals to 0, which is right now over here. And this will essentially define if it's alive. If it's less than or equal to 0, actually more than, my bad, because this is going to return a true. So more than or equal to, more than 0, not equal to. Jesus Christ, I'm slipping up, I'm slipping up. There it is, equal, more than 0, and if it's more than 0, then the character is alive because this will return true most of the time. So there we go. It's a very simple solution, very simple setup, but it will allow me right now to sort of check if my character is alive, and if my character is alive, I will say print the string, except I want to do this and not this. It should be true. And is it currently alive? Well, it's going to say true, so let's just keep it green, right? So that we have these two together. Now that we know now that the green bit, okay, the green bit is actually the, our character EX. So far, so good. We have our received damage and event damage. The event damage, when fired, will check if our character is alive. Once the check is complete, it will be printed out in the situation above, right? If it's, well, this needs to stay for 15 seconds as well. Good thing I saw it. Right, so very simple. Same thing goes for event received damage. Whenever you call something that's receiving damage, you're going to pass in the damage amount. Generally speaking, you shouldn't be passing the armor, but whatever, right? Let's just say that this is kind of a special situation. So we will pass the damage amount and the armor, and we'll subtract it from the health, and the health remaining, and set the health, and print the final health to screen. Very, very easy stuff. Now you might think, why would you do all of that stuff in such a fashion? Because if I go to my player controller, imagine for a second that I want to damage anything that is damageable. Anything that is damageable. Okay? Generally speaking, you'd be using this. because we'll be using the message, I'm gonna show you here, since you wouldn't be damaging everything from your player controller ever, well, unless in a very special situation. But the point is that if I grab my receive damage, as you can see, I can, if I disable this, I have a message. Now the message itself takes any target. That's the cool bit about interfaces, okay? They take any target. I'm showing you this inside the character EX because I can't really, I don't want to do a lot of stuff in the player controller, since I can't actually overlap in it with anything in the player controller, all right? The player controller does not have a physical presence. But the point is that, as you can see, this little message bit here will essentially send anything that overlaps here. It will send a request to execute receive damage, right? This should be very clear to you. The cool bit is that I don't need to cast, all right? In general, I would need to cast, but if the other actor does not actually is not damageable, does not have the damageable interface, this is not gonna, like, it's gonna fail silently. It's not gonna give me an error. It's not gonna throw me an issue. I'm not gonna crash. Nothing bad is going to happen if the other object does not possess the interface. And that's the power of the interfaces. They essentially enable you to decouple all of this casting over here, and allows you to simply send messages, and whoever implements the damageable gets damaged. Whoever doesn't get damaged. And it's very simple to utilize as well. As you can see, we have, like in this case, this is a very bad setup, but if you were smarter, you could modify your functions over here to represent exactly what you need to be happening in here, and perhaps the armor wouldn't be available, wouldn't be part of the function itself, or maybe part of the function later in the health remaining, where the calculation is going to be happening. The point is that maybe you have a heavy orc, a super heavy orc, a tree, anything, and it could have some damage reduction, which is only logical. And you could actually calculate this based on a case-by-case basis, where with the other object, like with the casting, you're only you have to do this one by one manually, right? So the interface is very powerful. That, with all that being said, so how am I supposed to trigger this? Well, very simple. I will simply grab my character EX, right, over here, compile. Now in this case, I'm gonna have to cast. Okay, here's my character player controller. So let's grab let's actually call something out of the blue. Let's say receive damage. As you can see, we're messaging something. That's a message, and then is alive, I believe. What was the other one? Life check. Life check. Let's go for a life check. Oh wait, no, just damage. Sorry, damaged. There it is, damaged message. Now all of these are messages. Notice that all of these are messages, and you don't need to implement. This class here does not implement the damageable situation. This allows me to treat anything that implements the object as the object type. Okay, let me just put it this way. If you are a sniper, if you are a soldier and you possess a sniper, I can treat you and all the other snipers as snipers, even though you might not have bazookas. Okay? Like if I have a sidearm and I'm if I have a sniper, let's use the sniper situation. If I have a sniper and a machete, right? I'm technically not a sniper. Or if I have a sniper and an assault rifle, I'm technically not a pure sniper. Now, if I want to be utilizing people who have snipers in any capacity, I could utilize an interface. If I want to use snipers who only possess snipers, I will do this in a different fashion. Okay, I hope this makes a little bit more sense. So the types, this adds a different type. So not only is my character EX called character EX type, it's also an damageable type. It's also damageable. I cannot explain this any clearer. So let's go ahead and simply damage message it. There it is. So we got two messages. As you can see, they have, of course, execution lines. It requires a target. Remember, it takes any object, but it does need to take an object, generally speaking, because you kind of have to tell it, well, where do you want me to send the message, right? So let's say I grab, in this case, get all actors. Get all. There's no way to get all actors like on the actual level, is there? I simply want to get all actors. Is it possible to get all actors? No, unfortunately not. All right, well, let's just say we grab all active. Well, there's no point. All right, let's just grab character. Get character. There it is, get player character. And this player character doesn't have to be anything. Currently, I would have to cast this. Remember, if I wanted to use this, I could say, oh, cast to player EX. Cast to character EX, my bad. Right? This is what I would have to do without having access to an interface. I would have to do this for every object that I interact with, okay? Now, in this case, I simply need to send this to the target. Now, if my character in any shape, in any way, shape, or form has the sort of the HUD itself, like the player character currently, I should be able to use it. And because my player character is set to be by default character EX, right? I will actually be able to utilize this. Of course, if it was just pawn, then it's a little bit higher. I would have to grab the pawn if I wanted to, or implement it on the pawn if I wanted to get it to work. I hope that's fairly clear by now. Now, where was I? There's my character. There's my player controller. And I'm going to compile. And I need some kind of an executable, right? I need execution, so I'm going to say, because I'm in the player controller, spacebar. We already have spacebar. Yeah, so I'm going to say D key, D key, double D. So I'm going to say whenever I press it, I want to receive, send the message to receive damage. And when I release it, I want to check if the target is still alive. In other words, did I kill it? Did I not kill it? What's the story? Of course, it's going to give me only a true or false. I didn't do any appends or anything. What I'm going to do is simply send damage amount of, let's say 150.8, because why not 0.8? And the armor will be 73.59. Yeah, we're gonna do that. So as you can see, I'm sending an amount because of course I know that the armor should be lower than the damage amount. Otherwise, we'll be sending a negative damage. In a normal game, you might have to check if the armor does not exceed the damage, or so that you don't accidentally add health to the player. So that's one thing to watch out for. Now I'm going to compile, and as you can see, we have no errors. Now the moment of truth is, is this going to work if I press D? Yes, it does. My player currently has 172 health left, and he is alive. If I press D again, I'll deal another bit of damage, and it's going to be 95 health. If I release, it's going to tell me, yeah, he's still alive. Deal it again. Oh, he's almost dead. He's almost dead. Do it one more time, and it's going to be, it says false. Our character is dead. So why is that even cooler than you might imagine, than you might already understand on your own? Because, my friends, I can do the same in the pawn. I can do the same in any other object that utilizes iDamageable. And the moment I get that object, whichever way I do it, I could get it through a function. I could get it through, this event that I just deleted. Let me just re-enable this event here. Generally speaking, whenever you talk to different objects, usually it happens when they interact in some fashion. So either being an overlap or a ray trace, right? Could be some, I believe trace, just regular trace, was it? Raycast. Line trace by channel. As you can see, you've got loads of different traces, or hit result. Well, we need to actually get the hit result. So I forgot the name of the function now. Hit something. Hit something? Was there a hit something? It was something like hit. Raycast, hit, ray trace. Ray trace. No. What if it's just trace? Trace channel test, blah, 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 blah. Line trace, there we go. Box trace, line trace, capsule trace. Yeah, these are all basically traces. So let's just say I'm going to trace line trace by objects. Let's line trace for objects, and there it is. We've got return values and the hit. We could break the hit. And as you can see, we got a lot of information from tracing a line. Obviously, you have a start and an end, and a bunch of other settings to work out with, if it's a trace complex or not, etc., etc. But at the end of the day, you've got all of this information to work with once you trace a line. So as you can see, you will always get the object desired. There's many ways to get the object desired to reference, and allows you to create things such as death traps, right? If something is immune to fire, it will simply not have a burnable interface. Or maybe it'll have this interface, but it'll have a different implementation of the interface and will burn by healing itself, okay? Therefore, if you had this event begin overlap with the mesh, in this case the fire pit, you grab the actor and you tell it to, you know, send the receive damage version. Of course, in this case, I don't have my game mode. I don't have a overlap situation. But what if I get a a trace channel? For crying out loud, trace by profile for objects. There it is. I could probably just grab the object if I split the structure pin and grab my hit actor. Oops. Out hit actor. And there it is, in the target and in the target. So right now, this is legitimately a system. If I delete this, this is a legit system of essentially shooting people. I can't recombine this. Okay. In other words, every time I press D, there will be, of course, well, presumably there's going to be some kind of logic behind this, right, to run the execution down the line. But I will be able to shoot them because I'll be able to receive damage, whatever damage I send them, and we'll be able to damage their armor, right? Now, the important thing, again, to note between the two, one requires casting, one does not. One is type-specific. One is also type-specific, but it does not require you to actually cast the type. It allows you a lot more flexibility, and it also does not require you... It's by the way also stackable. So let's just say that we could create another interface called iHealable. Generally speaking, by the way, even though iDamageable, if you pass negative values into iDamageable, you're gonna get a heal. So because you'll be adding this to the health. Generally speaking, it's always best to split your interfaces in functionality. So there's gonna be iHealable, right? And this could be another blueprint. For example, if this was some sort of an inventory, it could be iStackable. In this case, we wouldn't really worry about the type of item. So if this is a wrench or a bolt or a nut or some kind of apple, fruit, whatever, as long as it goes into the player's inventory, it will be stacked. Okay, you'll add it to an array and you will stack the arrays. The array, basically your inventory will be one array and the stacks themselves will be a smaller array, or essentially a number of how many you have. You could also do it like that. You can have an object in, you know, an abstract object such as an apple, and then an integer counting how many apples you actually have. Something like this. So there's loads of different ways to perform different functions. So stackable, healable, all of these are of course available. I'm going to delete them because we're not going to use them. And like I said, I could do the same to the pawn, right? I could simply grab my pawn, go to my class settings, and boom. It's got iDamageable. I can compile. I already have the damageable stuff. If I had something else, I could add that. Currently, of course, these are, let's say, tutorial BP interface. So I could add this, even though it really doesn't add anything. But now I have two implemented interfaces. So right now is no. Let me just show you this one little bit as well. I shouldn't have deleted the iHealable. iHealable. So currently I have a function. I'm not even going to name this function. Just going to keep it like that, compile. What's important here in the pawn is if I go ahead and say iHealable as well and compile this. And well, for fuck's sake, I should have named it. What's the name of this thing? iHealable, new function, of course. Let's just call it heal. Heal. Just easier to access. As you can see, no inputs, no outputs, nothing, no categories. Generally speaking, you should categorize your stuff, by the way. So as you can see, I have my stuff here, and we should say heal, and we could call event heal. Of course, we could also call the function heal. Notice that, right? There's my event heal, and I could grab and I could continue working with the other events available to me through, through the interface itself. However, the interesting thing here, right now, my pawn is both damageable and healable, allowing me to cast to damageable. Let's say cast healable. And I can also cast damageable. As you can see, there's a difference between the two because now if I do some logic that, let's say, grabs all actors or does whatever, and my pawn is healable, it will only heal the pawn. All right. Let's say I grab all the actors, the pawn and the character gets, dumped into this whole grab. Once I get them and I cast to iHealable, I will only perform a particular function on the iHealable, because in this case only on the pawn, because the character is not healable, it's only damageable, right? Very simple. I hope I really tried to make this as simple as possible when it comes to interfaces. I believe I hammered it down really well. If you're still in the video, I commend your patience, right? All right, now that being said, we are done with interfaces for now. Well, no, we're just done. So what's the next step? How can we make something even more awesome? There's another thing called delegates, aka event dispatchers. They operate in a slightly different fashion. Now, if you were to think of the interface as the type of soldier in the army, so let's just say we got an army soldier, and he could be a sniper, he could also be a gunner, he could also be a tank guy, he could also be a mechanic. So a guy could be both a sniper, a mechanic. There's a lot of professions, but he's a talented guy. So maybe we want to only utilize him. Maybe we want to address all snipers, including him. But the thing is, you kind of you can't really call all of the snipers. In other words, you have to really overlap with them, or you need to have something interact with them. You need to have some kind of a trigger to do that. And here's the kicker. When you don't have the trigger, you're still screwed. Okay? You don't have the trigger. What are you going to do? And what if you need more people? What if you need everybody to listen to it, to listen to your orders? That's where event dispatchers come in. Let's go ahead and do this like that. I'm going to go to my player controller again. We're kind of running out of keys here. So the next one will be S key. No, what am I doing? S key. What's wrong, dude? Key. Where's my key? Jesus Christ. Okay, R. R is closer. I grabbed R. Now, let's just say, for our sake, that we want to have a particular event happen. Heal. Let's say we want to heal our objects. Now, I'm going to ignore the fact that we already have an iHealable result. And I will say, I'm going to create a new event dispatcher. And I'm going to say, oh, well, please heal. Heal, please. Please heal me. So what I'm going to do now is heal, please. I'm going to call it. I'm going to simply call it. And I'm going to say, guys, just heal. Right? Heal me now, you bastards. So there's my heal call for help. Cry for help. I'm going to compile. Obviously, we're going to get an error here because we don't have a target at this point. Okay, let's just grab get player character just to get this nice and working again. Not that we need it though. I'm going to compile this. Now we have our event, which is happening when I press R, and we're going to call for help. Who's going to listen to us, right? We need somebody to be listening to our call for help. And this will be our character EX, of course. I'm going to compile this just to make sure it all works. And we will continue further down this line. Right? Heal, please. Do I have a heal? Let's do this. Yeah, I know what we're going to do. So I'm going to say heal, please. Assign heal, please. And I need to, of course, remove the context sensitive bit. As you can see, I've assigned heal, please, and I should probably rename this thing into heal target now. Heal him now. So, as you can see, it requires a player controller object reference. So you do need to have an object reference. Currently, we only have the game mode stored, so I'm simply going to grab player controller, right, and I'm going to simply dunk it over here. No need to set it as a variable. My bad. As player controller EX. God damn it. Cast to. Ah, come on. Is there no fast way? Cast to player controller EX. Jesus Christ. Right. Kind of missed the IntelliSense on the Visual Studio for that. Then we've got the object type, which would be get player controller. What? not get player. I need to get a new keyboard controller. As you can see, I have it right here, get player controller, and of course I need to begin play in order to actually have it run. All right, so when the game begins, in other words, when I start the game, we'll get the player controller, we'll assign it to, we'll cast this to player controller EX, and as the player controller EX, we'll bind this event called Palooza Help to our heal target now, right now. And let's just say that this is going to have some kind of variable. I don't know if we're using the damage or not, so health received, and I'm going to make this into an integer and simply make it public. It is public already. Just make it public like that. Currently, we have nothing because it's not compiled, and we're going to have, currently it's 0. Now, here's the cool bit here. Of course, this is kind of a one-way thing, right? I hope you understand that this is sending a cry for help, and then whatever everyone else does not matter. All right? This is really not how you would do the heal bit, by the way, but I'm simply illustrating a point. So if I grab my event here, and I already have a reference to my game mode, okay? Or is it game mode? Oh, no, is it my, it's my player controller. I'm going to essentially set health. How are we going to do this? Okay, I'm going to do it like this. So set health received to be initial health received. So get health received, which is if anyone else received it, healed them already. I'm going to plus float times float, not float. Plus integer times integer plus integer, like so, and I will simply say that the amount healed will be in my case 50. This will heal for 50 health, and I will send the current health received. I'll set it as, in this case, 50, right? Very simple. So whenever something happens, we'll fire away, we'll basically cry for help, and I will simply copy this, by the way, since this will be very useful for our pawn. Compile and save. Next, I need to do the same thing in the pawn because I want several different party members in this case to be listening to my plea. So I'm going to go into my pawn. I'm going to essentially say call, well, just, what was it, heal please. Of course, it's not available. And we're going to call heal please. Here's the interesting bit. We don't want to call it. What am I doing? Heal please. We want to bind this to some event. Now, because this is a healable, right? It could be a designated healer. I could say, you know what? You could fire this off by 2 different ways. Because we have interface, remember, I'm going to say a heal. This should be already fairly, it should be locking in for you guys. There's my heal, right? And I grab the event. I hook it up. Now, I can call the heal by using an iHealable interface and by using a delegate, or in this case, an event dispatcher. All right. I need, of course, to do the same bit here, what I did in the first place. So I need a target for that, like this, and there's my target. And the event heal, I could also grab my health, get health received, and I will, however much I've already received, and I will say, see, unfortunately, there's going to be, by the way, an issue here. You'll notice it real quick. Set, well, actually, it's plus integer plus integer. Wow, this is a lot easier to get connected. So I'm going to add 100 here. Now, here's an interesting bit. If this works correctly, well, incorrectly, I should get 150 health, but it probably will not. My bad. Health, sorry guys, I'm just getting this. It's been quite a long talk here. Maybe I should have split this video up, but I do want to connect everything together so it makes a lot more sense. So there's my targets. Again, I'm not going to use a reference, simply use my default target, and I'm going to compile. Now, what do you think is going to happen? What do you think is going to happen when I call for help? See, because these things will listen to me at the same time, they will fire off at the same time, they will set this value at the same time. So I'm not sure which one will prevail, but it's either going to be 100 or either going to be 50. That's why this is not an effective system for healing. However, nevertheless, it will illustrate the point flawlessly. At least that's my belief. Currently, of course, this is a self-target because we already have this here, and I can play the game. I believe this is not going to be an issue because do we have the pawn in the game? No, we do not have the pawn in the game. That is quite unfortunate. So let's grab this over and drop it in the game. And maybe we could also do the world settings, turn it back into pawn EX. Now, let's go ahead and run this and see what we got. I need to compile this, by the way. Okay, let's play. Excellent. D is not going to work because my pawn, I'm getting the pawn instead of the character and the character, so I'm not going to get my damaging thing. If I press R, oh, I'm not printing any strings. Jesus Christ. I don't know what happens. I need to print some strings. So let's go ahead and do that. I'm simply going to print the string here and say print string and say, well, what do you want to print? I want to see how much health I received. My current health received. Currently, it's 0, of course, by default. When I start, it's 0. Presumably, when I call for help, these guys should do their own little thing. One should add it, and we should get the result. All right, let's play. Press R, 250, 500. Oh, actually, they do add quite a lot. Okay, so let's show you how this actually happens. 150. Why am I setting it for so high? What am I doing here? This is 0, and character is it gets 50, so I should get 150 instead of, oh yes. You see, the problem here is that my pawn and my character is a child of the pawn. Therefore, it executes its own thing, but the pawn also executes its own thing, so it runs the character and the child at the same time. So that's why I'm getting twice the results. As you can see, first time, instead of getting 150, I get 250, and then 500, and then 750. That is because this is being called twice, right? That's what you have to understand. In this case, of course. Obviously, you wouldn't be doing these like I'm doing them right now. This is kind of idiotic the way I'm approaching this. But I want to make room for some of the more nuanced concepts, okay? So that's how the delegates work. If you really want to look at it, I suppose we could simply, how are we going to do this now? If I play this in the game, and I Alt P, and I simply, well, how am I not going to possess? I want to possess this thing. I'm going to simulate. What if I simulate? Press R. Nothing going to happen. What if I have it here? Is it simulating? I don't understand. Just simulate, boy. There it is. I'm pressing R. Nothing happened. What if I possess it? There it is. Unfortunately, we're not debugging, and that is something that needs to be rectified almost immediately. Oh, come on. So currently, we're not really seeing much. I'm going to have to debug. Well, I'm going to have to start simulating, then I'm going to have to debug this damn thing. There we go. Now there's my player controller. I'm pressing R. I have to possess. Press R, and as you can see, I'm sending pulses into call, and we could even take a look at, like, obviously that's why you would want maybe more monitors. But if I unpossess this, is there a shortcut for possessing? F8. Oh, it is F8. Okay, that's pretty cool. I kind of thought that Alt P was the thing. Oh, Alt P was the. All right, I get it. Never mind. Never mind. So if we go ahead and take a look at the character now, which is also over here, which perhaps needs to be on the left side like this, much better, and we will check our character debugging info here, and there's our bind. Notice what's going to happen now if I simply possess by pressing F8. There it is. Boom. Perhaps I need to unpossess for a second here so that we really get the right stack. So there's my call, pressing F8, pressing R, and this is not debugging as well. Okay, this one more time. Possess, press R. Okay, there we go. Now this should be as clear as it is, right? Something is listening to the call for help, for the cry to help, and we can have as many objects. That's the cool bit about the delegates. Anything out there can be listening to this. Okay, maybe this shouldn't have been like this. Yeah. Anything out there can be listening to my messages. Anything out there could be listening to my call for help, or maybe, hey guys, I just got into a trap, or hey guys, I just went over this bridge, or hey guys, I just entered your dungeon, come and kill me. So all of these types of messages are available for your utilization, and they work quite well, if I dare say so myself, with the interfaces. Okay, make sure to utilize both of them, because this is defining the framework of your game. The bigger the framework of your game, the more scalable your game must be, the more you must utilize events and interfaces. In fact, if anything, try to minimize your direct blueprint to blueprint communication in favor of events and interfaces, because it'll allow you to scale your game massively. Obviously, it depends on what kind of game you're making. Since we'll be making a worm volleyball game, there really isn't that much. I mean, what are we going to scale? Are we going to make this like an MMO, right? So there's really no need. We can go very simply in the game mode. Just probably all of the logic is going to be handled in the game mode, despite that being a bad idea. So, as you might imagine, it's a very powerful tool. Now, there's a couple of other methods here to utilize this function. Now, my character EX has quite a lot of things going on for it, right? Imagine if I wanted to have, maybe I've created a weapon, like, I don't know, like a laser cannon, right? So here's my weapon, laser cannon. I'm going to say create new blueprint. And let's just say we got 2 points. We're going to make two blueprints. One is going to be actor component EX. I'll explain later what this is. And I'm going to grab my blueprint class. I'm going to say I want a, well, really, actually, there's not a lot I can use here. Let's see if I can grab something from actor. I don't know. There really isn't that much I could use. Let's say just an actor. Let's say another actor. We already have an actor, don't we? Yes, we do. So let's just open the blueprint here, and let's make this actor into a, oh, I don't know. Obviously, these components here are a lot. I'm just going to get a static mesh. And I'm going to make this static mesh into a, well, ray gun. Let's say this is a ray gun. Okay. And I'm going to say, well, I do believe we have a capsule. Do we have, there we go, narrow capsule. No idea what that is. Yeah, so narrow capsule. And I will probably have to sort of rotate this guy like this, right? And maybe move it to the center a little bit. So let's assume for a second that this is our ray gun, okay? I know it's ridiculous, but, you know, just bear with me. And I'm going to have in my event graph a function called, I'm just going to create a new function. I'm going to say this is my obliteration, obliterate function. It's got to do absolutely nothing, but it will exist, right? So I'm going to compile this here, and it will exist on its own. It just has a signature. Now here's my actor X, and I also will open my actor component EX. In fact, I'm going to call this Grim Reaper EX. And this guy is going to have a very simple function. Notice there's a difference, by the way, between the actor EX and the Grim Reaper EX. So this currently, of course, has one function to override, which is, of course, end the play. But it's got a bunch of interesting situations where we can essentially start stacking up functionality. So if I create a function, so let's just say it and create a function. I'm going to say this is my death function. So whatever this object is attached will have the power of death, right? Because it's the Grim Reaper. Now, I believe this is compiled. Yes, it is. And we can go back into, what are we going to attach this to? To the character. Yes, the character will receive all of these blessings and boons. So let's grab our component. Let's see what we have. Do we have a actor EX? No, we do not. That is very unfortunate, is it not? However, we do have a Grim Reaper EX. So as you can see, you can add functionality to your sort of actors in terms of components. Right here, we can take a look. We should have right here in the components. We should have a reference to the Grim Reaper EX, and from that we should be able to grab what's its face, the death function, right? And there's the death function, and it's got, you know, whatever it is it's doing, it's doing. The point is that even though you can add many different types of objects here in the component menu, if you want to define your own in terms of utility, you're gonna have to create the Grim Reaper EX, or you need to define children of the actors themselves in order to you know, grab, for example, arrow components or mesh, etc. Again, the important bit is you can inherit some items. I believe it's possible. I'm not entirely sure if you can create some stuff over here and you can add them in components. I'm pretty sure you should be able to do that, by the way. It's a Bluepring class, is it not? Why do you not want to? Let's grab my character here from this side. I wonder if I am able to simply drag this and drop this. Okay, so it works. For some reason, because I remember having done that before. Let's say this is a ray gun. All right, so I can edit the blueprint. And as you can see, we don't have the actor. Okay. For some reason, this does not really work the way I expected it to work. Ray gun? No. Why can I not get it? Actor EX? No. Very unfortunate. I'm not entirely sure how to get the damn thing to the components, but I know it's possible because you can drag and drop it over here. Okay, so I do think there must be some fashion here. I want to add this component to the capsule component. Yes, I do. And there it is. And now I want to, what if I simply create a new blueprint? Right. Doesn't work out. Okay, I'll leave this with you guys. You figure out how to do this. But what we're going to do, by the way, here in this case, is going to create a child blueprint class. I wanted to do that anyway. And I'm going to say it's going to be in content, in the temp, and it's going to stay a character EX child. Yes, child. Let's go. And there it is. It's created. Yes, I have my ray gun. So there is one way of doing it. It's a child actor component. I see. It has to be a child actor. Yes. And then you get to define which child actor do you actually want to use, I believe. I'm not sure. I'm not entirely sure how you can add this in an easy way. Oh, there it is. Actor EX. Okay. There it is. All right. We got it. We got him. That's how it is. So you add a. I'm sorry. I have. It's been a while since I had to do that. But I hope you understand how this works. And now, since you have it as a component here as well, not only do you get the inherited bits from your other components, you also get the functions from the begin play of our character EX parent, which is all that jazz. You also get all the functionality of these, for example, when you press spacebar, etc. You also get the functionality of the Grim Reaper, and you get the functionality of the Actor EX, which is the Obliterate. If I write down Obliterate, I don't get it. I should be getting it. Get Child Actor. Obliterate. Do we not have the function itself? Oh, yeah, we need to actually grab something off. Obliterate. Jesus Christ, come on, dude. There it is. Actor EX. It requires an Actor EX object reference. This is a child actor. I see that's an issue. It is an issue, but I believe it might work. No, it won't work. I have to cast this. Cast to Actor EX. So there must be there's some finicking around here, so maybe that's not the best approach. I'm not sure. I know for sure that components are useful, such as the Grim Reaper in this case. But I believe if you add stuff such as an already done weapon, like in this case we have a ray gun or ray blaster or whatever, you should be able to access its functions. Let's try our original character here, which is, yeah, everything is already done and dusted here, so therefore that's the end of that. Now, as you can see, that is a very simple way of operating. Again, the Grim Reaper itself, sorry, I need to really close these. So I'm going to close the Grim Reaper, the actor, the player controller, the pawn, the game mode, and we're going to keep these three here, just because I wanted to show one final thing. So far, you know, so many different ways to communicate between blueprints. One last thing, because our character EX is inheriting from the character blueprint. I need to compile this guy. What is it? Okay, I don't know. Just forget about this thing for a second. I thought this would work the way I thought it would work, but clearly it did not. What if I compile now? Oh, you bastard. All right, let's get rid of this for now. I'm pretty sure there was a way of doing this. I just forgot how it is. It doesn't matter, as long as you can use, generally speaking, you'll be using components anyway. But if you get it down, well, go to the documentation and learn it yourself. I don't want to bother with this. It's been a fairly long video as it is. The point is that now, because this is a child, I get access to all the variables available to me here, such as max health and the current health. So let's say max health. Okay. Get max health, actually. Get max HP. There it is. Get max HP, get health. Well, there we go. We even have the functions. Heal target now, and what else do we have? Heal, health remaining. We got different functions such as health remaining. So as you can see, I have everything that's available to me in the character EX is also available to me over here. By the way, I kind of forgot to mention this. If something is private, such as this, for example, health on its own, it's private. Notice that I cannot get it. It's literally gone. Even if I remove the context sensitive, it's simply not there because it's private, right? If I do the same to the to the max HP, if I make that private as well, now the child is truly screwed because this should not be accessible. Is it? It is, right? Yeah, it's gone. Yeah, it's gone. Like this is gonna fail if I try to use it for anything. Let's say print string, and it's gonna tell me no, that's not how it works. Warning, no. There it is. So as you can see, that's how you can monitor and manipulate the amount of information that your child and your parent sort of gets. Of course, it's also possible to use protected, and you can do the same, by the way, on your functions. So in this case, I have a function called, I don't know, health remaining. So I could say that health remaining is, where's my health remaining? Health remaining is all, I cannot edit this. Okay, life check. What can I use from my parent? A heal target now. There it is. We're going to use heal target now. There's the event. And god damn it, I can't. Okay, let's create a new function just for the final point here. Okay, I can't actually find it later down the line. Texter. It's a texter function. Now currently it's public. Compile. But if it's private, even though it's private, the child in this case, what do you think is going to happen? Sorry, just write down texter. Oh, I do have it, even though it's private, right? Here. See, it's private, but it's still callable. That is annoying, at least for me. But that's how it works. Protected, this should be the protected behavior. So protected should allow it. If it's protected, then it should I should be able to access this not heal target now, but this texter. All right, so I'm going to call the function texter, even though you can even call the either call the function or call the event. Obviously, it doesn't matter in which case, because both of these are kind of you know, it's got nothing on it, right? That's protected, and let's see private, if private is going to work. Yes, it definitely will. So, quite unfortunate. Let's try to do this again. Compile. Yeah, no errors at all. So that's all, guys. That is basically all the ways in which you can communicate with your objects. It's quite a lot, but yeah. Now, in order to hammer this down completely, I will again use the example, as I stated before, with the military, with all situations. Case number 1, the library of functions. The library of functions is essentially like a military dogma or military decree, which says you will fold your uniform in such and such manner, this and this and that, blah, blah, blah. Everybody has access to it. It's like the Bible of the military. Next is number 2, which is direct access. This is essentially like going from point to point and telling people what to do precisely and exactly. Okay, if I was the sergeant, for example, I would just say, soldier, I want you to clean your weapon. Which weapon? I want you to clean your primary weapon. Which primary weapon? I want you to clean your primary weapon, which is also a assault rifle. Which assault rifle? I want you to clean your primary weapon, which is also an assault rifle, which is your AK-47, not your M14 or M16 or whatever it is you're using. And then the soldier will execute the command. Then you have the interfaces, which allows you to address a whole platoon of people, really, your whole army, all the soldiers in your army. You can basically tell them, right, if you have green boots, you're out. You're kicked out. You're out. You're fired, right? Anything that is green bootable will be booted, right? That's how you would do it. You wouldn't care who, like if Private John or Private Bob or Private Ivan or Private fucking whoever, if they in any way, shape, or form disagreed with your command or failed the test. The test being, if you got green boots, you leave. And of course, the final one, which is the delegate, in this case, allows you to communicate with just the people who are listening. All right. In other words, as high command, you really don't care that much about the soldiers themselves. You only want to communicate with the lieutenants, but your lieutenants are spread across a lot of places, and you also keep recruiting lieutenants all the time because the old ones keep dying. So you need to somehow be able to communicate with them. So all you do is simply send a message, and whoever's listening to that message is gonna act on the event. Note, however, please note in the character here, I just failed to mention that in the character controller. Please note that it is possible to have the reverse. Okay, in other words, instead of calling for help, this could be my main healer, right? Have an event attached to it, like so. Where is it? Okay, I can have an event like this, and only one. This would be my one execution guy. Every time, you could have 1,000 people out there. They will say, "Heal me now." This guy will heal them because there's 100 people who can call onto the event, and this guy's bound to it. So you're not limited to one call or one bind. You can call from many places. You can listen to many places. Generally speaking, it's more acceptable to use only one caller or only one listener. You don't want it to be a clusterfuck. If you got like 10 callers and 10 listeners, it kind of defeats the whole purpose of the delegate, right? You'd be much better using something like an interface, for example. All right, and then you've got your components, which allow you to modulate. This is a composition-based functionality where you compose your blueprint by adding functionality to it. With, in this case, Grim Reaper would be our functionality. It's got death on it. Whoever has the Grim Reaper, it also has the death function, which is part of the Grim Reaper package. Then, of course, you have your inheritance mode, which allows you to inherit this stuff. So you can compose something and then inherit from it, and then whichever inherited it could also get composed. Therefore, it's not a mutually exclusive way of inheriting stuff. Now, if you combine all of that, you have a very powerful tool set of communicating and setting data and working with logic between blueprints. You can also compartmentalize quite well when it comes to information and logic as well. And you can split your game to as granular a piece as you want to. You can make everything work in the game mode only. You can split it up into components. You can split it into groups, split them into interfaces, and the further down you go, the more possibilities you're going to get. You can have an interface that's hooked up to a delegate, which is listening to some kind of a component command, which is on one of the components, and that component command, whenever you add it somewhere with the blueprint, you can actually call on that. Loads of different combinations. And of course, if all else fails, you can simply directly speak to stuff, not to mention that you got arrays with which you can work with, store information and structures, data sheets, loads and loads. It's pretty much an infinite amount of possibilities you can get. Literally, you're limited by your imagination here. And one more thing here to note is that you don't want to get too confusing when you first make your game, all right? You want to get a fairly straightforward type game. You don't want to kind of, grab, all right, I'm going to have, oh, this is damageable, healable, edible, killable, a bunch of other stuff, right? And then you just lose track of what's what. Although it's definitely, there's definitely ways to find that, what is actually damageable or healable, etc. All right? With that being said, guys, I cannot stress this enough. Understand these concepts and you will be golden. All right? It's a lot like with Legos. You either have a hat or you have a set of blocks. You could use the hat, but if you wanted a hat which is bigger, just use the building blocks to make a bigger hat. Okay? And that's the way it goes in Unreal as well, in pretty much any programming language. If you don't have something that is provided to you by the library, make your own. And maybe share it with the world once you've done it so that other people don't have to do it. Again, at the end of the day, it's all about reusability. I want to be able to use this Grim Reaper on 100 different actors. Okay, I don't want it to be usable only on this one actor. Maybe I want to use it on a gun, on a player character, on an NPC, on a tree, on a plant. Right? It's my problem what I want to use it for, so I'm going to have to make it in such a way. Same goes for the interface. Notice that I made it a very stupid interface where I had to kind of, tweak it a little bit so that it worked. That's not how you would do an interface. I simply wanted to illustrate how would you use different functions on that interface. That was a long video. All right, guys, that concludes Blueprint programming in Unreal Engine 4. This is just the tip of the iceberg. There's a lot of stuff to read. We didn't even get into any sort of networking, and we're not gonna in the near future. However, with this stuff now, with all of the knowledge that you have right now, you don't even need to watch me making the game, which I will do at some point. However, you can do the stuff on your own. Right now, you're completely, fully equipped with the knowledge of Maya, with the knowledge of Painter, with the knowledge of Mudbox, if you actually ventured into that. I kind of forgot to upload some videos about that. Knowledge of version control. You're never going to lose whatever it is you're doing. Everything will be saved and backed up. You have knowledge of the any import and export problems. You know how to fix them, how to sort them out, how to implement different things into your pipeline, maybe Photoshop. And then, of course, you have the knowledge of how to operate Unreal Engine 4. All you need from now on is kind of to start experimenting, right? Grab a couple of objects here from the left, make something happen. Grab a cascade system, sort of like a particle system, which is the cascade. Take a look at how it works. Maybe make an animation. Maybe check out how the menu works. Now, we're going to go over these in the way I'm making the video, but generally speaking, conceptually, you're now only limited by your knowledge of other systems in Unreal. And of course, you're just like a tadpole when it comes to programming. There's loads and loads and loads, like a pretty much infinite amount of stuff to learn about in programming. Again, as a developer, you probably want to know a little bit of everything. You also know how to program shaders, by the way, in Designer. So, yeah, there's a lot. There's a lot of stuff that you should know by now. All right, guys. With that, I will leave you. Do whatever it is you want to do. And in the next set of videos, we'll actually make Wormy Ball a reality. Bye-bye.